Hi everyone, welcome to today's video. In this video, we'll be pricing equity derivatives and we'll be using some numerical and mathematical models to uh, to simulate it in C++. So first we'll be starting with some basic European call options. So this will be starting with a plain vanilla option. So we'll not be making things complicated. It is quite a simple example. We'll be starting with this simple example. Then we'll be proceeding with multi-asset simulations and other type of derivative simulations as well, which will be like interest rate, credit derivatives, and forex derivatives as well. So first we'll be starting with the vanilla European call option. Let's say there is an XYZ stock. Uh, this is the underlying asset. So there are let's assume there are two counterparties A and B in which this contract in which so let's assume there are two counterparties A and B, which both of which are agreed to this particular contract. So for t is equals to 0 at this particular time, so A pays B a premium, which is also known as the premium of the option. And let's say after t equal to t years, maybe 1 or 2 years or whatever, at the time of maturity, so A will have the right but not the obligation to buy this particular underlying from B. So this is going to be at the strike price K. So the profit that has to be assumed is going to be maximum of the initial price minus the strike price and 0, which is A did not. So 0 will be that A did not exercised his rights and he didn't buy the underlying at that particular time. And if he had bought, so this is the profit that he would have made. Now second will be, so second is the math model that we'll be using for its simulation. So underlying is a stock, XYZ stock. So this can be generalized as a GBM or a geometric Brownian motion. So the equation for this is going to be ds rsdt plus sdt. So where r is the interest rate and sigma is the volatility. And the numerical method that we are going to use is the Monte Carlo simulation, and the computation of the value at the discounted price, it is going to be something like here again r is the interest rate. So this is a typical Monte Carlo simulation model which you can go through in some other books. Will not be going into details. I'll make a separate video if that is necessary. So now what we are going to do is we are going to write down the algorithm how we are going to simulate it. So first and foremost, what are the input parameters? Second So this is the algorithm part. So we'll be writing this in C++ code, algorithm part. So first is going to be the input. What are the input that we have for that particular option? Second is going to be the simulation loop. So in this particular loop, what we are going to do is we are going to compute the geometric Brownian motion. Third, we are going to compute the payoff of that particular option. Now, in the fourth step, when we get the payoff, we are going to discount it to the present time. And then in the end, we are going to output the premium. So this is going to be our algorithm, and what are the mathematicals and the numerical models we are going to be using. So let's get into it. So the input parameters what we are going to use is first let's define n as the number of steps in GBM. So and m is going to be the number of Monte Carlo simulations. And then we have our XYZ stock. For that we are going to assume only $100 of strike price, 5% let's say the interest rate IR, and volatility is going to be let's say 10%, and time of maturity let's say 1 year to keep things simple. Okay, so yeah, so this is pretty much it. So one thing to note here is, so these mathematical models that we use are for continuous time period, but the stock prices that we are talking about of maturity, let's say 1 year, so the time is not continuous, rather we'll be using the discretized version of this mathematical model, discretized version on time. Okay, so let's get into the code. Okay, so here we have our equity derivative main. So random.cpp and random.hpp. So in this we are going to define our function so that we can have a discretized model rather than the continuous time period model. So for this, we are going to use the Gaussian Gaussian deviates using box Muller method. So yeah, let's get into it. So first we are going to include our random.hpp easy and simply include bits stdc++.h using namespace. Using namespace, and we are going to define our box simple box Muller as below. Now we have a few parameters which will be, let's say, res x and y and x y square. Now we'll be having a loop which is while this xy square is greater than equals to 1.0 and x is going to be 2.0 into, we are using a random function which is double max and then -1. So these are simple mathematical formulas that you can have, that you can see from anywhere. So one example is this. So this is box Muller transformation. So this is a box Muller transformation that you can see on Wikipedia. So you can find that C++ code as well, but they are using uh, normal distribution with the polar forms using the cos theta and sin theta as well. So that is different. So yep, that's pretty much it. And we have xy square, which is x into x plus y into y. And in the end, we are going to simply return our res, which is equals to x into square root of -2 simply return res. So here we are going to simply define box block. Okay, so now we are going to write our main code, which is hash include So this is our going to be our main function, and step one, we are going to define the input parameters. So here we'll have int t, which is the maturity. We have int k as 100, which is our strike price of that XYZ stock option. Then we have again int spot price as 0, which is again, let's say 100. Then we have double sigma, which is our volatility, which we had defined as 10% volatility. Then we have our interest rates, double R, which is 5% interest rates. Then the number of steps. So this is for Monte Carlo, and this is for GBM. Okay, so next we are going to define our function array, which is the n plus 1. So this is going to be the price of s, the price for each this GBM, after each GBM. Then we are going to have our another variable, which is premium, and payoff, which initially let's define as 0, and we'll define dt, which is 1 divided by n. Okay, so now here is the simulations. So for I++, for that we are going to initialize our s, which we forgot, which is s of 0. So initially the price is 0, right? So this we forgot to define, and then for int j is equals 0, now we have our double epsilon, which we are going to get from our box Muller. So this is simply to discretize that particular equation. So this is dt into epsilon. So this is done as of j, and then we are going to compute the payoff. So we are going to compute the payoff, which is going to be max of s of n which is strike price. Okay, so this would come here. So basically, we are reusing this particular array for all the simulations, right? So this is our payoff, and now we are going to do is discount the payoff. So if we discount, our premium is going to be the formula that we had just seen, exponential of r into capital T into payoff divided by. So yeah, this is the premium that we need to pay for these parameters. So yep, let's build this particular thing. So what we are going to do is, so it is g++ fed1 main.cpp random.cpp Okay, so this is built. So what is the output? So for this, let's have a look at the payout. So this is the executable, and there's a premium. भाई okay, yep. So here we have Monte Carlo European call, and the premium for XYZ stock after GBM and Monte Carlo is 10.58. Okay, now let's say if we increased the GBM count. Now if we run this, what we'll get? Okay, 10.58. Hmm. Okay, so this was a simple Monte Carlo European call option to calculate the premium.